Welcome back to another lesson in MCR3U. Today we'll be looking at properties of quadratic functions. So if you recall, some of these properties of quadratic functions, remember quadratic functions have constant non-zero second differences. Remember if you look at first differences, so constant first differences, again, means that it's linear. So constant second differences here then indicate to us that it's quadratic. And here, second differences are positive. Second differences are positive. The parabola opens up, and the coefficient of x squared is positive. If the second differences are negative, the parabola opens down, and the coefficient of x squared is negative. So let's look at this example here. It says, is the following relation quadratic? If so, determine the direction of opening. And so here, if we take our first differences, so our first differences are taking again y2 minus y1. So here we have 3 minus 0 is equal to 3. 4 minus 3 is equal to 1. 3 minus 4, which is equal to negative 1. And 0 minus 3, which is equal to negative 3. So the second differences are taking the difference of the first difference. And so here, I'll just draw these. So here we have 1 minus 3, which is equal to negative 2, negative 1 minus 1, which is equal to negative 2, and negative 3 minus negative 1 is equal to negative 2. And so here we see that these second differences are constant, and we have a negative second difference, or second differences, which means that it is opening down. So again, our parabola will open down. Okay. And here there's also three forms that we can write quadratics in: standard form, factored form, and vertex form. And each one of these forms tells us some different information about the quadratic. In standard form, we have y is equal to ax squared plus bx plus c. We know that the c value is the y-intercept. And the direction of opening is determined by the a value. And so if the a value is positive, that means it opens up. And if the a value is negative, it opens down. And something to note here is that for all three forms of the quadratic, the a value stays the same. So even if you're converting between standard form to factored form, factored to vertex, so on and so forth, the a value stays the same in all three forms. So in factored form, we have y is equal to a x minus r, x minus s. Those are our factors, or our x-intercepts, our roots, or zeros, many ways to indicate that. And again, the direction of opening, again, is determined by the a value, which is the same as standard form. Positive opens up, negative opens down. And to find the roots, x-intercepts, or zeros, equate each factor to 0 and solve for x. In vertex form, here we have y is equal to a x minus h squared plus k. And as you would expect here, the vertex form provides you with the vertex, which is h and k. Again, here, if a is positive, the minimum value is at k, and if a is negative, the maximum value is at k. And this is also known as the optimal value. Okay, so here we're going to determine the direction of opening of each of the following. So here, negative a value opens down. For b, positive a value opens up. So let's look at this here. It says given y is equal to negative 2, x plus 1, x minus 3, determine the zeros. So here we will have x plus 1 is equal to 0, x is equal to negative 1, and we have x minus 3 is equal to 0, and x is equal to 3. So our zeros are at negative 1 and 3. If you call it the axis of symmetry, how we find that is there's a couple ways to do it, but here we can add the x-intercepts and divide by 2. And remember, the axis of symmetry cuts, again, the graph in half and is also the x value, the vertex. So the x value of the vertex and also cuts the parabola. Okay, so here, if we add our two x-intercepts, negative 1 plus 3 divided by 2, which is 2 over 2, which is equal to 1. So our equation of the axis of symmetry is x is equal to 1. So our vertex, if the axis symmetry is the x valued vertex, we can sub in to find the y. So y is equal to negative 2, 1 plus 1, 1 minus 3. So here what we did was we subbed x is equal to 1 into the equation. And so y is equal to negative 2 times 2 times negative 2. And so the y value will be equal to 8. So therefore, our vertex is at 1 and 8. So now let's graph it here. So remember, we have a 0 at negative 1. We have another 0 at 3. Our vertex is at 1 and 8. And so we can graph this, and we know that the a value is negative, so it should be opening down, which is what we see here. Okay, here it says write the equation of the parabola in standard form. And so we know we have two zeros here to start. So we're going to start in factored form and then convert into standard form. And we also know our c value here as well. We have a y-intercept at 0 and 6. So here, what we'll do, again, we have our factored form. So we have y is equal to a plus 2 and x plus 3. And those were our two zeros are at negative 2 and negative 3. So we have a x plus 2, x plus 3. Here we're provided with the y-intercept, which is what we'll use here, sub in, and that should be our c value when we convert it to standard form as well. And so if we sub this in, we have to find our a value. So 6 is equal to 0 plus 2, 0 plus 3, and 6 is equal to 6a, and therefore a is equal to 1. So here, if we have y is equal to x plus 2, x plus 3, convert to standard form, we will expand it. So here we'll get y is equal to x squared plus 2x plus 3x plus 6. Here we see that our y-intercept is 6, which is good because that's what's given to us. So our equation standard form is x squared plus 5x plus 6. Okay, this last one here, it says find the value of a in the parabola that has zeros 2 and -4 and a y-intercept of -1. So here we have zeros, so we don't have our a value again. That's what we're trying to find. Has zeros of 2 and -4, so x minus 2, x plus 4. And we have y-intercept of -1, which means that we can sub our value of 0 and -1, or sub our point. So here we have -1 is equal to a, 0 minus 2, 0 plus 4. -1 is equal to -2 times 4, which is -8a, and therefore a is equal to 1 over 8. And so here, our equation will be y is equal to 1 over 8, x minus 2, x plus 4, with our a value being 1 over 8.